Was there like do we have any of these not these programs but any of the CSC programming classes? Are they gonna go on like the Raspberry Pi? Yeah.
What did you get read? Oh, did you get them in 175?
Yeah, a while back. I don't even know. Just kind of got them and forgot about them.
Oh, that's interesting. Well, some students have used them in senior seminar for their project, but I'm trying to think what class might use them. I mean, we could, they're possibly usable in systems programming.
I mean, they're pretty cool. Like I used one in high school, like 3.
Yeah.
I mean, we didn't get those.
What did you do with it in high school?
We used them for robotics.
I mean, I can see possibly using them in systems programming for remoting into it and writing all your software for the class on that, so that we can use the C compiler on Linux rather than having to kind of fake it on here. That actually might not be a horrible idea. But in terms of doing, I mean, that's just kind of treating it like a mini computer.
Right.
That's not doing anything. I mean, that's all Raspberry Pi is. It's a really small computer. I don't know. Let me think about that. It's a reasonable question. I wonder I'll ask them about it today at Bible study, what the rationale was for handing them out. Like, what was the intent?
Yeah. Even in that class, all we had to do was take a picture of it running, and we got extra credit. That's like the only thing
we
used it
in.
for.
Yeah, I don't mind.
Yeah, but that's actually harder and harder to come by because monitors are less and less common now since you have laptops and stuff like that. Yeah, they need to have a good way of getting the screen of that like on a laptop screen. I mean, you can remote into it, but then you have to know what the IP address is and stuff like that. I wonder, can you connect to it through USB?
Yeah. Got like a USB port on.
Yeah. But I wonder if there's like PC software where you can plug it into your USB port on your computer, and then your computer will find the Raspberry Pi and open up a serial connection to it, so that you can, have a terminal or something. Because like in 450, that would be kind of beneficial because we always have problems finding a hosted Linux environment somewhere that allows you to do Linux system calls and the C compiler stuff and things like that. We always use, last year we used AWS's hosted thing, but you're playing around with like how much CPU time you get for free and stuff like that. So using a Raspberry Pi might actually be kind of a cool thing if there's a convenient way of like just, when you want to work on your homework, you plug it into the, your computer so you have a monitor for it. Otherwise, if you don't just have an extra monitor sitting at home, it's less convenient to use, right? Or I guess that we can just say everybody gets Raspberry Pis and just deal with it. You guys find a place to.
It's not hard. You can just like unplug the monitor.
Well, yeah, and I get it, but that becomes it's okay here where we have, we do have the computer labs, the monitors here, but, like for instance, our Mac lab, they're all built in. Yeah, there's not a monitor to unhook. A lot of people only have laptops now. There isn't a monitor to unhook. I bet you there's a piece of software out there specifically for Raspberry Pis where you can hook it up through USB and get it on your screen. That would actually be something worth looking into because that would solve a reasonable problem in 450, even though it's not necessarily it's not a bad use of a Raspberry Pi. It's kind of like having your own little kind of portable Linux box that travels with you. Except the Raspberry Pis are a little bit big for that.
No, my dog was like this big.
Oh, is it? Because you can do like a bootable Linux distribution on a jump drive, but even then it boots slow, and then it's still kind of slow when it runs. Where a Raspberry Pi would be faster for the stuff we would use it for in 450. So that's interesting question. All right, so let's look at how we are going to represent our department. All right, so we've been talking about JSON and marshaling and unmarshaling, well, serializing data and deserializing data, or marshaling and unmarshaling. So, serialize is kind of our more modern way of talking about it. So we serialize it into from an object into a form like this, and then we deserialize it on the way back out. So now we need to come up with a, how do we represent the department? All right, so we have to think about it. What is the department? Is it a collection of rooms? Is that a fair thing? So we say it's a collection of rooms where each of those rooms has kind of a dimension to it, a length and a width. And we could say a height, even though our height's kind of standard across the thing, but it's possible to have to walk into a room that has a taller ceiling, right? Okay, so what is the department? Is a collection of rooms where a room has a length, width, height. Let's see, anything else we probably are going to want to add in like doors and things like that eventually, but just for our initial pass on this, let's keep it simple, where we want to kind of lay out the department, okay, in kind of blocks. All right, so we have a collection of rooms, length, width, and height. Now, if we think of this room here, and we say it's, I don't know, 15 by 20 or something like that, by, I don't know, however, 12-foot ceilings, let's say. It might be taller than that, but whatever. If that's our starting point, and then we say there's another room right next to it, this hallway, that's this elongated hallway or whatever, how do we create the relationship between this room and that room in the department? So we're going to have this JSON file that's going to describe our department, right? So we need to kind of have a way of, we can create a single room, right? We can create a JSON representation of a single room, read in the pieces of information, and then take a take a starting point, a prefab, and say I'm going to apply to the transform those sizes, and now we have that room. So that wouldn't be that bad to do, right? We can just read in the JSON. We've looked at reading in JSON and turning it back into objects. But at the same time, that just gives us one room. So we can build this room, we can build this hallway, but how do we make this hallway perpendicular to this room right outside the door? How do we create that scenario in JSON? How do we represent that?
We have to have a location as well, wouldn't we?
Okay. And then how do we pick that location? So tell me what that location might look like. So if we're drawing our department, so this might be our S120 down here, and then we're going to have our hallway kind of here. Just get a couple more rooms in here. Let's just say something like that. Let's throw a couple of colors in here for these guys. All right, so let's just say that's part of the department, right? So 120, 118, and then this is the Mac lab, and here's that hallway. Okay. Now we can build a little JSON representation of this guy and say he's length, width, height. Same thing with this guy, same thing with this guy, same thing with this guy. But now we ultimately want to get them placed in our scene relative to each other. And you mentioned we need to store maybe location. How do we create our location? How do we say the location of this guy, and then how do we say the location of this guy such that they will get placed next to each other?
Well, the location's in the middle of the room, let's say, right? So you could have it be like the start of, or it's like you could say, well, you could start off like one room at 0, 0, and then like have it be like, I guess like the width of like the hallway, or like the Y of the hallway is like, let's say like this room minus half its Y value, or plus its Y value. Then the half is because that's like the size of like that half of the room. And then
So you want to put it on a coordinate system. You want to have it like on an X, Y. So you want to pretend like there's a big placemat down here that has an X and Y in the middle of it. I think you were kind of saying that maybe we pick a room and this is 0, 0 or something like that, right here in the center of the room.
We could do that. Like the only alternative would be just placing it by hand, like.
So have it generate our rooms and then kind of drag them around?
Yeah, like that's the only other alternative rather than like.
I don't know if it's the only other alternative.
That I can think, I don't know.
So are we treating, in our model here, are we treating all of our rooms as rectangles of some sort, right? So they have 4 walls, right? So we can think of it as north, south, east, west, potentially. Okay, so if we think about this guy, this is the northern wall.
Yeah.
All right. And maybe we decide that you have a center point for the northern wall, and then things are offset from a center point on the northern wall. I'm just throwing an alternative out there, and then we can come up with other ideas off of that. Okay, so maybe we decide that the northern wall of this guy is going to be, because we already know what this dude's length and width and height is, right? So we say the center of this is 0, and then it's a offset from that 0. So maybe this guy is this next room is going to be offset at I don't know, let's say a -3, something like that. All right, and that's where we'll place him. Now we probably need to have some sort of common way of thinking about the starting point of a room. So what we see in a lot of kind of graphical user interface design tools, like with Android Studio and iPhone's interface builder, is they treat the bottom left-hand corner or the bottom or the top left-hand corner as the kind of the starting point. Okay, so like on iPhone, upper left-hand corner is 0, 0. Okay, so this would be 0, 0 all the way up here. And then we would say this guy is going to be bottom, and then maybe to the right 5 or something. And what am I actually saying is to the 5? I'm saying this dude's upper left-hand corner is there. So we reference each individual room by their upper left-hand corner. That way we have a consistent way of talking about what we're aligning up to what. So we're saying that this dude's left-hand corner is connected to this dude's southern wall at an offset of 4. Something like that. That makes sense?
Yeah.
That's a way we can do this. All right. So what we have done is we kind of have just agreed upon a way of referencing the location of every object by saying its location is its upper left-hand corner. That's its starting point. And then stuff that's underneath it is relative to that guy. Now, if we go that route, then what we end up having to do is we end up having to have we have to have almost a hierarchy of things. So if I use this as my picture, just going to scoot this over so I can add a bullet point thing. So I'm just going to label these. Let's say this is room 1, room 2, room 3, room 4. So we're going to have to kind of create a hierarchy of rooms. So we have room 1 is going to have its length, width, and height, right? So we might say that this guy, let's see, can I add bullets here? I can indent underneath, that'll work. All right, so we're going to say that this guy is, what, 30 wide, 15 by 12. So let's call it 30, 15, 12, something like that. All right, that's that guy's length, width, height.
There's no drop down menu on the bottom right. Bullets in the line.
Oh, there is. Okay. We would have been able to accomplish it using this indent thing too. Yeah. All right, so this is our top room. So now all the other rooms are now children of this guy. Because if we're going to do everything relative, so we're kind of picking a starting point, and then everything else is relative from that starting point. Okay, so this is one way we might accomplish it. All right, so.
So would you build 4 relative to 3 then, or would everything be relative to 1?
I'm going to build everything relative to 1.
Okay.
Let me left justify this. In this model, and then we can decide that if we want to do it a different way. So now what we would say is we would say that 2. Now this guy might have a position of so let's just comma delimit it here. So we're going to say that he's not off of anybody's wall or anything. He's the top level. So maybe we say null. Or why don't we just say none, and then an offset of -1 or something like that. Since there's not anything we're offsetting him, we're just placing him. He'll be somewhere, and then we can drag the entire object around. So then room 2 here has, he looks like a square, so we're going to call this guy 20 by 20 by 12, and then he's going to be well, we can actually deal with these guys as a hierarchy. So we don't even have to say a none here. We can just say we have to have an offset and then we have to have a wall. I guess we do need none. So we're saying which wall and then what offset on that wall. So this guy is going to be 20 by 20 by 12. He's going to be off the southern wall of this guy, and if we're treating everything in the upper left-hand corner, he's going to be at an offset of, if his width is 30, is going to be an offset of -15, something like that. So we'll call this guy south -15. So this guy has a width of 30. We're going to go to its south wall. Here's the center point, and then -15 gets us to the location of 2. Where his upper left-hand corner is. Kind of see how we're laying this out? All right. Now, similarly, this top-level guy is going to have another room that's offset underneath him. Now, we could offset it underneath 2 if we wanted to, but so if we offsetted it underneath 2, this guy would have his length, width, and height, and his location would actually be the east wall of 2 at an offset of 10 to put it here. So one way we can write this, so if we want to see it that way, we can say that room 3 is going to be, let's see, probably has a width of 5, a length of 40, and a ceiling, a height of 12. It's going to be east wall, and then it's going to be a offset of, so east wall puts us here in the center, and then plus 10, half this guy's distance. Something like that. So that's one way we can represent 3. Alternatively, we can represent 3 by placing it as a child of 1 and saying that this guy has a 5, a 4, but he's actually off the southern wall of 1 at an offset of, I don't know, 3 or something like that. See how so both of those are valid ways of representing this guy's position. All right, then we can represent 4's position as a child of 3. So here's 4, and 4 looks like it's the same size as 2, so we'll just say 20 by 20 by 12, and 4 is going to be off the south wall of 3. So here's the south wall of 3, and see, actually, this is an interesting way. So it's actually going to be a bigger offset than the width of the room. So here's the south wall center, and then we're going to say maybe minus 5. Something like that.
Is it just minus because it's going left?
Yeah, where I just kind of treated things that go left are minuses, things that go right are pluses. You know, you just be consistent. So that is one way we could represent our, we could have the equivalent JSON to represent this current map like that. All right, not horrible. We're kind of picking a starting point and making everything relative to that starting point. What else could we do? We can decide that this entire thing is kind of on a grid, right? So we can put like almost a placemat underneath this guy and say that it's on an XY coordinate system. So maybe we decide that this 3 is kind of at 0, 0, something like that. So we can say the upper left-hand corner of 1 is going to be relative to this 0, 0 position. So given the size of these guys, this is going to be a x of negative 22.5 and a y of positive, that's 20, no, it's 15. So 35. So this would go from here, go the entire width of this guy, which is 20, plus the width of this guy, which is 15, even though they look the same. It's I'm just going by the actual measurements we gave it over here. So 20 plus the 15.
Oh, you count the offset?
Well, that is that. Now we don't have an offset because now we're just saying this is 0, 0. I'm just choosing the 3 as our origin of our axes. Okay, this is just a normal XY axis. All right, so we'll say, so from 3, we're going to position room 1's upper left-hand corner. So we'll decide that's where we're going to say the origin of every room is. We'll position it at negative 22.5, so that's half of this room, half the width of this room plus the width of this room. So 22.5. And then on a y of 35. So negative 22.5 and then y of 35. All right, then room 2 is going to be at negative 22.5 and a y of 20. That gets us the upper left-hand corner of this 2. And then room 3 is going to be at negative 2.5. And then, how tall is that? And 20. So these guys are no longer children of each other. There's individual rooms, individual objects. All right, and then 4 will be at -5, and then -20.
The only downside to this is if you want to change the size of one of the rooms going forward. Well, the first one has like at least some constraints to it.
Yeah, I don't think you're wrong. But in your first one, if we do change, well, actually, you're right. If we do change the size of this room right here, but we still put it relative to this room, all the other rooms should flow with it.
Yeah.
It might still end up looking weird if we design it poorly. But changing the size of one room, making this room a little bit bigger, should not impact. Let's see, would there be a way for me to make this guy?
But if you make like 3 wider, it'll like cut into 2.
Yeah, and same thing with 2. If you make 2 taller or something.
Yeah.
So I still think you need to make them line up reasonably well. This guy relies on you having kind of a giant coordinate system that you make everything fit in, where this guy here just makes you have these guys positioned relative to each other.
Is there a way you could have like, so like you're parenting all these off of 1?
Mm-hmm.
Like, is there a way you can like get, so like you have like south and stuff like that of like 1? Is there a way you can also like constrain off of like a second thing? It's like if you have like a wall or something on the left side, you constrain to the left then too, or do you have to offset off?
Well, you can offset off of anything you want as long as you have a way of referencing it.
Okay.
So, for instance, we don't even have to have these guys. We don't have to have it as a hierarchy if we don't want to. We'll just have to give these guys a unique ID.
Okay.
So, maybe we say the unique ID is 1 and 2 and 3 and those guys. So if I do that, then we'll just add one more piece of information here where 2 is relative to 1.
Okay.
And 3 is relative to 1. And 4 is relative to 3.
Okay.
Something like that. Now, if you do that, what we could do is we could have this guy right here be a JSON collection. So we can say that it's relative to 1 on the south wall at an offset of -15. We can then have a comma. It's also relative to 2 on its east wall. So we can have a collection of constraints, if you will. Definitely possible if that would benefit us. I'm not sure that initially benefits us.
Yeah, no.
Yeah, I mean, I think it'll make the design more complex. The ultimate goal here is it doesn't necessarily matter how complex this design ends up being, how we represent our JSON, because we'd ultimately want to build a tool that lets us do this, that will generate the complex JSON for us.
Gotcha.
But we need to first capture what that JSON should look like. So we shouldn't be too concerned about how scary this looks. Yeah, just by having a unique ID, I think you just have to have a way of referencing who this guy is other than having it parented.
Okay.
Because really what you'd have here is if we're doing this in JSON, this would be our top level object, and this object would have his own length, width, height, and then he would have within him a collection of objects. So this would be an array of JSON objects, which are other rooms. And then, because we talked about JSON supports arrays where the other guys do not. So this would be something that could be beneficial. It also sort of matches up to how game objects work, because one thing we probably want to be able to do is after we procedurally generated kind of an environment, we'd like to be able to just grab one of those blocks and drag the whole thing around. So if we had it as child transforms, that would allow us to have a single top level game object, and then everything inside of it would drag around with it. But we can accomplish that anyways by just having an empty game object that we throw all this stuff in. Does that make sense? So we don't even need we don't need one to be the top level if we don't want. We can just have a, department container or something like that all these guys are children of. So we build a single game object that is the parent of all our other game objects. That way, once it's actually instantiated on the screen, if we wanted to move it around, we could just grab the department container and everything drags with it. We're not dragging rooms apart and stuff like that. Okay, so what do you think? Which of these, do we like a approach where we're doing something relative, or do we like a discrete approach where we are actually placing things exactly on an XY system? This is probably the one we're going to be most comfortable with, right? I mean, this is just XY coordinates, and if something's a little bit off, we just go in and nudge his coordinate a little bit, and now he's good. If we change the size of a room, we then update the coordinates as well. But this guy is relatively set. You pointed out a reasonable concern that this guy having things relative to other guys will allow it to be maybe more malleable, but you could still create the situation where you have rooms overlapping other rooms. Do we have another approach? A better approach? I mean, whether this one is the best or not, it certainly feels very familiar, right? It's like, I'm going to create a game object. Here's its length, width, height, and this is where I'm going to put it on the XY coordinates. Done, right? You probably could throw a Z coordinate in here as well. And then for something where you don't know where the depth is going to be, because we're designing for 3D space, right? So you might want a Z coordinate as well. If you're, when you're building something, you might actually want to place it not here, but here, away from it. All right, so really this would be, an X, Y, Z thing, because right now we're looking at this from the top down. So kind of looking at it on the Y coordinate, if we're thinking about this in Unity. So we're placing them relative to each other. Now, that's okay in this case since they all share the same ceiling height. All right, so if we want to keep it simple initially, we can go ahead and just do it on an X and Y, and then we can expand it from there. Okay, but we're going to need something that will generate this kind of JSON for us, because ultimately what we want to do is we want to have JSON. We want to have a JSON string that has this stuff in it. Okay. Now, if we open up our Unity, it's still here. We had some stuff open from last time where we were using some of the built-in things with. We had our patient record, and we had to make these guys all public so that the JSON builder would create this stuff for us. So really what we would probably do here is we'd probably create another object, maybe called a room, because we're going to ultimately have a collection of rooms, right? Okay, so we'll create a room, and we gave it a toJSON thing here where we used our JSON utility toJSON, passed it this particular object, and it went and did the magic of taking all the public fields and turning it into stuff. And we also saw that we had an invoice array. Okay, because I mentioned that JSON supports collections, it supports arrays. Here is where's our invoice? Oh, we have it in the same file here. Remember, we had that issue with namespaces because of the way Unity handles their projects. So we had to kind of put it in the same file here because we're doing this all inside of Unity. We could choose to use a third-party tool to generate our JSON. You could even write it in Java or something like that. But since we have a good JSON tool here, throwing it inside the same class isn't going to kill anything. So we had to make this guy serializable here because we had it as a second class, just how the thing read it. So again, we have this guy has 2 public variables, so the JSON builder will pick them up. And then he has a 2 JSON, and this will convert it to JSON. So then up here, when we convert our patient record to JSON, it will give us, was it 4 name value pairs, 3 are strings, 1 is an int, and then it'll have a 5th name value pair where the name is invoices, but the value is an array. So to use square brackets, because JSON is kind of based on C-type programming syntax. So the name of the variable will be invoices, but the value will be inside of a square bracket, and then it will be a whole bunch of JSON object representations of invoices here. Now, did we actually build these guys somewhere? Was that in our Cube patient record builder? Oh, we actually do it inside of our patient record. So for our patient record, we just went ahead and generated a, how many did we make? 10 random invoices. We just added 2.12 to the starting price of the invoice. So when we build a single patient record, we give this guy his name, his date of birth, his age, and then we go ahead and just toss 10 invoices in there. And then converting him to JSON, we went ahead and did the convert back thing here. But what we really want to do in our example, just so we can see the JSON, is we're going to go ahead and just return JSON, because this is going to be the JSON version of this object. We wrote a convert back function here that marshals it back, proving it worked, but that doesn't show us the intermediate step. We want to, I think the example, you were the recipient, right? So you had a program, I had a program. I need to convert it to JSON, toss you the JSON, then you would convert it back into objects. We were doing it both at the same time, proving it moved in both directions, but let's go ahead and see the JSON here so we can see that the array structure for it. So I'm returning the JSON here, and then I'm printing the result of that out. So let me go ahead and run this, and we should see a nice collection of stuff. Okay. I'm going to copy this. And I think we saw that if I bring it into here, it was readable. All right, so we have first name Mike, L name Littman, date of birth, age. Notice that date of birth, well, notice that all these were strings, so they're surrounded by double quotes, but notice that age was an int, so it's not. So that guy has a type built into it. All right, for putting it back together. Then we have our invoices. So again, this is name, value, name, value, name, value, name, value, name, but the value of invoices is a collection. So we have our opening square bracket here. So that's an array. And the first element of the array is this guy right here, comma, here's the second element, comma, third element. There's 10 of those guys in here. Finally, here's the end of that value. And then here's the end of our original JSON object. Make sense? So this is the JSON representation of that patient record that has a collection of 10 invoices. All right, so this would be the string of data I can send over the internet to you that you can then take and put back together into an actual object, which is what we then showed last time. So you would then instead of returning the JSON, you would convert it back, taking in that string, build a patient record by using our JSON utility from JSON. This is called generics. So we're going to use this thing to build a patient record, passing it the JSON that was passed in, and then we'll go ahead and return that marshaled object. We wrote a little function called reverse first name that spins through and builds the first name in reverse, just proving that we got an object back last time. So if we go ahead and do that, this will be as if I'm building a patient record by converting it to JSON, sending it over the network to you in JSON. You're converting it back, then proving that you were able to convert it back by printing out the name in reverse. Because that's what this guy does. This guy returns convert back JSON. And what does convert back do? It returns the object that we just rebuilt, his reverse fname function, which returns a string that is his own first name in reverse. All right, so if this worked, we should see Mike in reverse. Okay, and there is Mike in reverse right there. You might not be able to read it, but trust me, it says Mike in reverse. All right, so that's the full process. We turned it into JSON, even though we did it all in one machine. I sent you the JSON. You turned it back into an object. Then you proved that that object works by calling that object's reverse first name and printing out his first name in reverse. Like, I got it. I actually was able to reconstruct an object. So effectively what we just did is we kind of created, if only it was this easy in real life, but we kind of created teleportation, right? We took an object, like a human, serialized it into its collection of atoms, representation of its collection of atoms, sent it over the internet, and then reconstructed it on the other end and proved that it was still functional. Wave your finger, stuff like that. Wouldn't that be cool? If you could just teleport somewhere and not break. You wouldn't be the guinea pig?
No.
Especially if they're doing like cats and dogs, and their tails are on their noses and stuff like that. It's like, well, maybe it'll work different for people. You wouldn't be that first person? What if they just paid you a bunch and you had a lot of confidence that you would live? You just might not be completely put back together right.
Or you're just like a blob, just kind of.
Well, you'd be a rich blob. Maybe I can pass you back through a couple times and just see if they can, whatever you do, make a backup of the JSON. Because whatever you got wrong the first time, I want you to send it back through. All right, but we feel okay doing that with our objects like this, right? Okay, so we understand the whole serializable, deserialized, blah, blah, blah. All right, so now what we need to do to convert this into what we're planning on doing for our department, we want to create, instead of a patient record, we want to create an object maybe called a room, right? Okay. Now, really, if we want to follow the model that we have here, we might call this maybe we're creating a room collection. And we would create an instance of room collection called CS department. And inside of that room collection, we would have a collection of rooms, just like we have a collection of invoices in this example. We'd have a collection of rooms where a room has a length, width, and height, as well as an X and Y coordinate. Okay, and with that in mind, we probably could then say a room collection has a starting location where we get to choose where the initial 0, 0 position is. Does that make sense? You know, in our little example back here, we just kind of randomly said 0, 0 is on this 3. That's just where it is. But with a room collection, we can maybe just choose where the origin is. To make things simple, we'll just go ahead and use Unity's origin of 0, 0, 0. That's where it, you know, it already has a 3D space. All right, so let's go ahead and build the objects that would represent this. All right, so I'm going to create a new C# script, and we're going to call this guy a room collection. All right, we'll go ahead and open that dude up. All right, so here's our room collection. Now, we know we're going to go ahead and need a room, so let's just steal our systems. Oh, perfect. Well, that is kind of helpful for larger font, but so we will steal this guy. Because we're going to be building a second object down here. And we'll call this guy public class room. Now remember, this dude is not going to be a monobehavior. What does monobehavior do? When we have room collection currently inheriting from monobehavior, what does that make it do?
You know, like kind of the rules Unity has conflict.
Yeah, so it's the thing that makes update get called every frame and fixed update get called 60 times a second. And yeah, I mean, this makes it a Unity compatible script that does all the Unity stuff. Well, we don't want this guy to be one of those. We want him to just be a plain Jane C# object. Now, that doesn't mean he can't contain Unity things. In fact, we're probably going to have him contain a prefab, right? Yeah, we'll probably have him contain a room prefab. So actually, with that in mind, let's think about this. Well, let's leave it for right now, and then we'll come back to that when we actually want to, because initially we're going to create the JSON, right? But once we have the JSON and we have the object, then we want to be able to actually turn that JSON into stuff on the screen. And at that point, we're going to have to make the bridge and say, okay, I need to create a cube game object, and I need to get it onto the screen. I need to get it into my scene. That makes sense? So we're going to have to figure out how that's going to go. But initially, I think we can just do it this way. So we're going to say a room collection. We're going to have a public X origin. And maybe we can start that off at 0. And this is going to be an int. Public int y origin. Start this off at 0. Public int z origin. Start off at 0. Okay, even though we're not using z's for our other rooms yet. Just for the room collection, that's going to be the guy that's we're going to pick that center point. Okay, where it is in our scene space. So 0, 0, 0. All right, and then this guy's also going to then have a collection of rooms. So we're going to have a public room array. We'll call this guy the rooms. Okay. I do wonder if this will allow us to do it with lists. But for a starting point, let's just get it working this way. Although I do wonder. I'm going to test something here real quick. I'm going to go into patient record. And instead of having this as an invoice array, I'm going to say public list of invoice called invoices is equal to a new list of invoice, like that. And then when we build it, I'm just going to say 10 here. It's probably like a dot add. All right, let me see if that does what I wanted to do first, and then I'll explain what I just did. Well, if it does mic in reverse, then it did what I wanted it to do. Give me a moment. All right, it's a useless object right now, but it should be one that compiles. Good. That's the mic in reverse. I'm going to run it one more time just to make sure it did that. It is clearing on play, isn't it? Just to keep myself sane for a moment. Just change it to David. Different first name. Just want to make sure it reverses it. It did. Good. All right. That's actually very helpful for us. And let me explain why. So going back into patient record, I'll just ask the class the question first. I think at least two of you should know the answer to this. All right. What's the advantage of doing something like this versus an array? Yeah, so lists are like our linked lists that we learned in 300, right? So so this guy, we'll say the problem with arrays, we say arrays are fast, that's what's good about them, but the problem with arrays is they are a fixed size. So we had to say, oh, we have exactly 10 invoices in this case, as opposed to saying, okay, I want a collection of invoices. I don't know how many I'm going to have. I happen to give it 10 this time, but I could give it 30 or something like that. Well, when we're building a room collection, we don't necessarily know how many rooms we're going to have, right? We'd like to have it be fairly, pliable, so we can just start adding rooms as we want to add rooms and not have to worry about changing the size of the initial array. That kind of thing. All right, so going back to our room collection then, instead of creating a room array, we're going to create a list of room objects. And this will be a new list of rooms. We'll go ahead and get rid of those guys. All right. And we will have, we'll add some more stuff up here in a second, but let's go ahead and start writing some stuff inside of our room. So we're going to say this guy is, we have a public. Go back to our design here. We're going to have maybe a room is going to have a name. A room is going to have a length, width, height. We just have to be consistent of what length means versus width, right? And then, we were going this route, right? And then a room is going to have a X and a Y coordinate. I was going to leave Z out, but we can throw Z in and just have it always 0 right now. Something like that. So we want to go ahead and throw a Z. All right, so This guy's going to have a string name. This guy will have a public. Probably, do we want our length, width, and heights to be integers? Or do we want them to be floating point values? How precise do we, I mean, if we're building rooms, are we going to build, will a room ever be like 13.113? They could be, but maybe initially it's just making mince. All right, so int length, width, height. All right, and then we're going to have a also an x, y, and z. All right, so those are our public variables for this guy. All right, we'll go ahead and create our constructor for room. And a room is going to take in a string name, and int length, int width, int height, int x, int y, int z. And we'll say this dot name is equal to name. This dot length is equal to length. This dot width is equal to width. This dot height is equal to height. This dot x is equal to x. This dot y is equal to y. This dot z is equal to z. All right, so that should build our object there, right? All right, then we need to give ourselves a public string. I think it needed to be called to JSON, right? Lowercase. Yeah, to JSON. And it didn't, I don't think it takes in nope, no parameters. All right, and this guy would return JSON utility, and it lived in a, is it system.json utility? All right, it is not finding JSON utility currently. It could just be a kill this and reopen. All right, it's happy with it now. So this guy will return this guy to JSON. We'll go ahead and build our constructor here for room collection. So public room collection. We'll take in an int x origin, int y origin, int z origin. This dot x origin is equal to x origin. This dot y origin is equal to y origin. This dot z origin is equal to z origin. All right, now we need to be able to add rooms to our collection, right? All right. So to add a room, we're going to need to get the room's name, its length, width, and height, and then its location. All right. So we're going to go ahead and we're going to have a public void add room. And this room would take in a string name, int length, int width, int height, int x, int y, int z. And then we'll go ahead and add to our list of rooms a new room built with these things. So this dot the rooms dot add new room, passing it name, length, width, height, x, y, z. All right, so we will pass this information in, build a brand new room, add it to our array or list of rooms, and everything should be good. Make sense? All right, so we have a toJSON there. Now we need to give this guy a function for toJSON. Public string toJSON. And this guy will return JSON utility.toJSON, passing it this particular object, which should create the string of this particular thing. Now what we'll do is we'll just, for testing purposes here, we'll steal our cube patient record builder thing that we used before, and instead of creating a patient record, we'll go ahead and create our room collection. Now, room collection, we just gave for the constructor, we just gave it an origin for X, Y, and Z. Probably want also a name. So we can let's say public string name for a room collection, like we would name this guy CS department or something like that. Okay. So then out here, we'll go ahead and we're going to create a room collection called CS department is equal to a new room collection. And room collection takes in a name. So we'll call this guy CS department. It takes in X, Y, and Z. So we'll pass it 0, 0, 0. Let's put it at the center. Okay. Now we want to go ahead and start adding rooms to this. Okay. And we can use our model that we built over here. So we're going to add room. We'll just name them room 1, 2, 3, and 4 for right now, since that's what we named them on here, even though we know they have room numbers. So we're going to have room 1 with the length, width, and height of this, and its location of this. Right. I'm actually going to steal this and see if I can. Good enough. Put it as a multi-line comment for the moment. Okay, so we're going to say CS department.add room. We're going to add a room named 1 with this stuff, length, width, height, X and Y. Oh, thank you. All right, and these guys, we do need them to be floats for the X, Y, and Z. right? I don't know if we tested. Did we test to see if double worked? Guess we'll see here pretty quick. Yeah, in general, double also tends to be our the default like way we represent floating point numbers in programming, even though Unity, as well as like, which is based on top of older C game engines, typically uses floats. So we could use floats if we wanted to. I'm more interested in for a moment just to see if the JSON converter will use doubles, or if this breaks it. I can always fix it pretty quickly. All right, so there is our value here. I did save it, right? Oh, origin, we can leave at, well, we already changed that to doubles. Might as well leave it at doubles. It's really this guy down here that needs to change. So this needs to take in doubles. All right. So technically these should be 0.0s, but it will cast it. But just to remind us that it is taking in doubles. We'll do that. All right, so we added one room, then we'll say CS department dot add room 2. And room 2 is this guy with an extra 0 at the end. All right, then CS department dot add room 3. And here's room 3. CS department add room 4. Extra 0 there at the end, like that. All right, then we should be able to say print CS department dot toJSON, which should return our string and should build that guy into a JSON-y thing. All right, so let's go test that. We'll see if it works for floats or if it screams at us. It did work. So here's our console. All right, so there's the JSON representation of our rooms. Not too bad. All right, so what we want to accomplish next time is, now that we have a way of creating object representations of our rooms and creating the JSON, later on we can have a tool that allows us to kind of, almost like build a room, stretch it out, and say, like click a button that says, you're JSON now. go to JSON. But now we want to translate this into actually having crap up on the screen. That make sense? Okay. Question, where are we at in our game? Do we have, I know I gave you a bunch of assignments out front leading up to Thanksgiving, or we're out of assignments now, right? Okay, I won't give you one for Thursday so we can get caught up on this, but risk of quiz on Thursday, let's say, related to what we talked about today. And then I do want to have a goal of finishing up that game before the end. So I'll go back and look and see where we are, because next semester for Game Programming 2, we're going to look at the next game, and then we're also going to do a first-person shooter with networking stuff. So actually what you'll do be outside of class, you'll be doing the RPG. And then in class, we'll be looking at stuff like this with networking stuff, multiplayer stuff, and first-person shooter thing, with the hope that you complete the other game in the first half and then have build your own first-person shooter in the second half. Multiplayer first-person shooter thingy. Sound cool? Are all of you registered for the second game programming? Okay, cool. All right, so I will see everybody on Thursday. Remember, student, faculty, staff, Bible study today at noon. God and grub. Go to the cafeteria, sign in, get a free lunch, take it down to the terrace room. I'll save a seat for you. Also, plenty of room in the front row of chapel. I'll save a seat for you up there as well.
Wait, what? What number is the game program?